Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So today in this video, we will study about the volume, what will be the volumetric strain for a rectangular as well as a circular bar section here. So what is meant by volumetric strain is nothing but, so the change in volume to the original volume, that will be the volumetric strain, because the strain is nothing but what, change in dimensions to the original dimensions. If it is a volumetric strain, so it's nothing but what, it's a change in volume to the original volume here. Now if I take the volumetric strain epsilon V, so it's nothing but what, it's a change in volume by original volume. So this is called as a volumetric strain. So this is volumetric strain is also called as a dilatation here. So this volumetric strain is also called as a dilatation. Okay, now we need to find out what will be the volumetric strain for a rectangular bar here. So what will be that equation? Okay, now generally what happens when we apply load for any rectangular bar section here in any direction, so in all the direction, means in xy, in all the three direction, we can just see the stresses, right? So once if we just see the stresses, there will be a strain will also be there. The thing is what, if suppose for example if I apply an axial load in the x direction, the length will be increases. So means what, there will be dimensions will be changes will be there in the longitudinal direction. At the same time we can just see the lateral dimensions, either it may be a depth or either it may be a width, so it will be decreases. So means what, it affects on the other sides also. So let it be. So we'll just find out what will be the volumetric strain, what will be the equation for this rectangular bar here. Now I'll just consider the rectangular bar here. Consider a rectangular bar here whose dimensions are rectangular bar, so which has a dimensions of, means the length is L, width and depth here, dimensions L into B into D here. So length is there and the width is there and the D is the depth here. Now we'll just find out what will be the equation here. Now I'll consider, so because we know that the volume of the rectangular bar is what, so means what, if I take the volume V is equal to, it's a area into volume V is equal to what, it's a area into length here, that is a cross sectional area into length. Now the cross sectional area means, it obviously this one we have to take B into D, the length is L. Though finally we can write, so V is equal to, it's a B D into L, or otherwise I can write this as a L, B and D. This is the volume of this rectangular bar here. I just take this is some equation 1. Okay, now what I'll do here, so we need to find out the volumetric strain. So epsilon V is equal to change in volume by original volume. So I got the denominator part here, that is a L into B into D, that is the volume here. Now I need to find out what will be the delta V. So delta V means it's something like, okay, differentiation of this equation 1. So means what, I have to differentiate this equation partially here. Okay, now I differentiate the equation 1 partially, so that we can get the numerator part delta V. So the left hand side, if I differentiate this equation 1, okay, partially, the left hand side becomes, it's a delta V. Okay, now this is something like three variables are there, L into B into D. We have to apply the product rule here. Now product rule means what, so keep these two terms as it is and differentiate the third part, plus again the second term you keep as it is and differentiate the first part. Means what, we have to keep two terms and we have to differentiate the last term like this. We have to proceed. Now I'll just consider this 2 as it is, L into B, I'll differentiate first D, that is a partial, so LB into delta D. Similarly we will go for the BD as it is and differentiate with respect to L. Okay, now I'll keep this DL as it is, that like constant here, L into B, differentiate, so I'll keep this DL as it is here. So this is D and here it become a delta B here. Now this is the equation 2 because we have differentiated now. So this I will take the equation 2. Now what I have to do here? So I need to find out the volumetric strain, that is a delta V by V means. So delta V is your equation 2 and V is your equation 1. So means what? So divide equation 2, just simplification here, by equation 1. So if I just divide equation 2 by equation 1, so the left hand side becomes what? It is a delta V by, so the V. The right hand side is, so take the entire equation here, L B delta D, B D delta L plus L D and delta B, whole divided by the first equation is L B D. Now you just take the separate terms, means you just separate here. So this delta V by V means it's a epsilon V, that is a volumetric strain. Now if I separate here, I'll just write one more way. So this is L B D. So for the second term, it's a B D delta L divided by L B D. Now again for the third term, L D delta B whole divided by L B and D. Now in this equation you can cancel some of the terms here, L into B get cancelled. So here in this equation B D, here also B and D we can cancel. So in this equation L into D we can cancel here. Now the remaining terms are epsilon V is equal to, it's a delta D by D plus delta L by L plus the last term is delta B by B. Okay. Now we just see here delta D by D means what? It's a change in dimensions to the original dimensions itself. But the thing is what D means, it indicates with respect to the direction Y, means it indicates with the Y axis. Again the L means it's a longitudinal direction towards the X axis. So B indicates further towards the Z direction, means what? So change in dimensions to the original dimension means it's a epsilon, like a strain here. So but in the respective direction, respective axis, I can able to write here. So means what? This epsilon V is equal to this delta D by D, I can write it as, so since it is related to the particular axis here, so epsilon V is equal to, so since change in dimensions to the original dimensions and D by D is there, so D is with respect to the Y axis, I will write here epsilon Y. So again here it's a delta L by L, but it is related to the axis X here, so it is epsilon X, and the last B is with respect to the Z axis, I will write here epsilon Z. Means what? The finally epsilon V is equal to, rearrange here, epsilon X, epsilon Y plus epsilon Z. So means what? The volumetric strain for a rectangular bar is the sum of the strains in all the three axes, that is a epsilon X plus epsilon Y plus epsilon Z. I hope you have got this equation for a rectangular bar. Now we will go for the what will be the volumetric strain for the circular bar here.